Welcome to the first of 3 whiteboards about the lessons we learned from imaging that can improve OMERACT's instrument selection process. The focus of this whiteboard is the importance of making sure that domain definitions are clear. If you are not familiar with the OMERACT process, we recommend you watch our introductory videos available on the OMERACT website. Today we are going to talk about one of the important lessons we learned when OMERACT began thinking through the process of putting imaging instruments through the OMERACT Instrument Selection Algorithm, commonly known by its acronym OFISA. The OFISA process is used to see whether an instrument meets the OMERACT Filter pillars of demonstrating truth, discrimination, and feasibility. Let's now talk about terminology. When we talk about patient-reported outcomes, we use the term outcome measurement instrument to represent the instrument itself, for example a questionnaire, as well as the scoring system that we use to obtain a result to represent the patient-centered target domain, for example pain. The same is true for imaging. OMERACT uses the term imaging outcome measurement instrument to mean the scoring system applied to an image that is produced by an imaging technique such as X-ray or ultrasound to represent a domain such as inflammation. In this talk, for simplicity, we will use the term imaging instrument, which means the same as imaging outcome measurement instrument. For example, we can use an ultrasound imaging machine to capture an image showing bone erosion. The imaging instrument could be a scale that states if bone erosion lesions exist, either yes or no. Another imaging instrument might use a more descriptive 4-point grading system to describe the amount of erosion. The important point here is that when we use the term imaging instrument, we mean the scoring system applied to a specific type of image, not just the type of imaging machine or technique used. When we started this project, we weren't sure whether we could use the current OFISA process or whether we would need a different process for selecting an imaging instrument that is truthful, meaning that it measures what we want it to measure in an accurate way, can detect if some situations are different from others, so can detect change, and is easy to use in clinical research or feasible. In other words, we needed to figure out if we could use the same OFISA process for all types of outcome instruments, whether it was a score obtained through a questionnaire, a physical examination, a laboratory measurement, or a score based on an image taken by an imaging machine. After much thought, we learned that with some minor tweaks, the same OFISA approach can be used for all instruments, and that there are 3 important lessons that can be applied to all types of instruments, not just imaging instruments. Before we go further, let's explain how an imaging technique or machine works to see inside the body so as to find out whether the body's organs or tissues in that area are normal or is working as they should. An imaging machine uses energy, for example electrical, sound, or light energy that interacts with the body to create images or pictures. As mentioned a moment ago, it is important to understand that when we talk about an imaging instrument, we do not mean the imaging device or machine alone. Once an image is obtained from a machine, it needs to be read or scored in some way, and it is this scoring system that is considered the imaging instrument. For example, Joe had osteoarthritis and had increased pain in his knee, so he had an X-ray. The person who scored the image found that there was less space between the upper and lower bones in the knee joint compared to Joe's previous X-ray. So it is the measuring or scoring of the amount of space as seen on the X-ray image that is the imaging instrument. In this case, the resulting score indicates that the osteoarthritis is worse than it was on the previous X-ray. Another example is ultrasonography, which uses ultrasound waves that travel through soft tissue such as muscle and fluids, and they bounce back or echo to various degrees from structures with more thickness or density. This means the more dense the structure, for example cartilage compared to blood vessels, the more the waves bounce back to create an image or picture of these structures. We will use an ultrasound example later on.